So today we're going to focus on section 10.4, which is about solving radical equations. When we solve equations that have radicals or square roots in them, we're going to start by getting the radical by itself on one side of the equation and moving everything that's not under the radical sign to the other side of the equation. Then we know that the opposite of taking the square root of something is to square it. So we'll square both sides. Squaring and square rooting will cancel each other out and make the radical disappear. Then we'll have a nice equation that we can solve. So let's take a look at a few examples. When you look at question number 1, the square root is the only thing on the left side of the equation. So we have the square root of x equals 5. To undo the square root to get a plain old x, we're going to square both sides of the equation. So on the left side, the square root of x squared just becomes x. On the right side, 5 squared is 25. Question number 2, again, the radical is already isolated. We have the square root of 2b equals -8. So to get rid of that square root, we're going to square both sides. The square root of 2b squared is just 2b. On the right side, -8 squared is positive 64. And now we can finish solving for b. So divide both sides by 2. And b should be 32. When you take a look at question number 3, our radical is isolated on the left side. There happens to be a lot of stuff underneath of the square root sign, but the left side of the equation is just this square root. So again, we're going to square both sides. Squaring and square rooting will cancel each other out to just give us the radicand, -3a plus 12. And on the right side of the equation, 6 squared is 36. Now we can solve for a. So subtract 12 from both sides. So -3a equals 24. And when you divide both sides by -3, a should be -8. Okay, question number 4. Notice that we have radicals on both sides of the equation. This is a case where we are still going to square both sides right away. We can't quite isolate the radical on the right side of the equation, but by squaring both sides, we are going to make all of the square roots disappear. So when I square the left side, I already know squaring and square rooting cancel out. I just get the radicand, 6b plus 12. When I square the right side of this equation, I have to square everything. So 8 squared is 64. The square root of 6 squared is 6. And those two numbers get multiplied together. 64 times 6 is 384. And then we can finish solving for b. Subtract 12 from both sides. So that 6b equals 372. And when we divide both sides by 6, b should be 62. When you take a look at questions 5 and 6, notice that the radicals are not by themselves now. So here we do have to start with our first step of isolating the radical. Get the radical by itself. So in question number 5, we have the square root of 8x plus 1. So first we need to move that 1 over to the other side by subtracting it. so that the square root of 8x equals 4. And now that we have the radical alone on the left side of the equation, now we can square both sides. On the left side, we get 8x. On the right side, 4 squared is 16. And when we divide both sides by 8, x should be 2. In the last question, we also have to isolate the radical. We have to get the radical by itself. We're still using our opposite operations. We're still using order of operations backwards. So here we have to move both the 6 and the minus 3, but we're going to move that minus 3 first by adding 3 to both sides. So 6 times the square root of x equals 3. Divide both sides by 6. So the square root of x equals 1/2. Now when we square both sides to get rid of the radical, the square root of x squared is x. When you take 1/2 or any fraction and square it, you simply square the numerator and square the denominator. So 1/2 squared is 1/4. Please make sure that you complete tonight's homework, which is attached. Make sure that you show your work in order to get full credit.